Hello everyone. Hope I'm audible. Okay. Let's start this session. High yield revision for NEET PG. Okay. So this is our second session in PSM, where we can discuss the calculations. Okay, calculations problems in PSM. This is a continuation of the previous video where we have seen certain other previous problems. Now we are continuing with this current one. Okay, fine. Let us start here. Okay, with the first one. A family consists of 2 parents and 6 children susceptible to measles. There occurs a primary case of measles and 3 secondary cases within a short period of time. Calculate SAR. What is SAR means? SAR means secondary attack rate. Okay, let us see the formula, then we will come back to the question. So what is this secondary attack rate? Secondary attack rate is a measure of communicability. A secondary attack rate is a measure of communicability. That means how infectious the condition is. So what is the formula for secondary attack rate? Secondary attack rate is number of new cases occurring within one incubation period of exposure. Okay, suppose there is a primary case is there. Following exposure to that primary case, okay, how many new cases occur? So number of new cases occurring within one incubation period of exposure by denominator is total number of susceptibles. Okay, susceptibles among exposed. Okay, total number of susceptibles among exposed multiplied by 100. So the primary case has to be excluded both from numerator as well as from the denominator. The primary case means suppose in a class, okay, I am the primary case, okay, I am entering into the class. Let us assume all are susceptible. Okay, so following exposure to me, how many develop disease? Okay, it's a measure of communicability. And the primary case we have to exclude both from numerator as well as from the denominator also we are supposed to exclude here. Right, now let us see the question and we'll come back to the answer here. So how many 2 parents and 6 children? Okay, can you tell me what is the answer? So among them one primary case, and following exposure to the primary case 3 more cases have reported. Now what is the answer for this question? What is the answer for this question? Yes. So first is that, so number of new cases. How many is the new cases? 3. What is the denominator? Okay, so we have to exclude the primary case. Okay, remaining how many people are there? 7. But look here, this is measles. Measles, will it affect adults? Means no. It is a disorder of childhood disorder. Childhood disorder. So parents are not susceptible. So we have to exclude parents. So totally 6 children. So there occurs a primary case. So 3 children are developing the disease. So multiplied by 100, this gives 60%. So the answer for this question is 60%. Are you able to follow this? So secondary attack rate. What is secondary attack rate? Following exposure to primary case, how many people developing disease? Among the people who are exposed, and also they should be susceptible. Not everyone, susceptible population. Hope you understood this question. Some of you may say that why not parents? Because this is measles, the disease of children, so it will not affect adults. Okay, does not affect adults. It's a disease of children, so parents are not susceptible. We are excluding the parents from the denominator. We'll go to the next question. These are basic problems, basic concepts. In a population of 5,000, the number of new cases of TB is 500. Okay, so population is 5,000. So old case is 150. Okay, and what is the prevalence? The question is prevalence, guys. Prevalence. Now we'll see the concepts, then we'll come back to this question. The question is related with prevalence. What is prevalence? Prevalence is number of current cases. A number of current cases may be old plus new. Maybe old case or new case by population population multiplied by 100. It comes in percentage. So number of current cases. Okay, how many current cases are there by population multiplied by 100. So what does this prevalence will tell you? Prevalence will tell you magnitude of the health problem, how big the problem is. Magnitude of the health problem. Second, prevalence. Which study will give you prevalence? Yes, can you able to answer? Excellent. The prevalence is what? Cross-sectional study. Cross-sectional study. Cross-sectional study will give you prevalence. Right. Now we'll go back to the question. We'll go back to the question here. Yeah. What is the answer here? So this is prevalence. The question is prevalence. So number is current cases. Current cases old and new. So 500 plus 150 by 5 multiplied by 100. It comes in percentage. So how much it is? 650 by 5000 multiplied by 100. That gives what? 13%. So the answer for this question is 13%. So prevalence, the answer here is, what is the answer? 13%. Prevalence is number of current cases. Current cases means both old and new. Hope you understood this. These are basic problems. Go to the next one. Incidence of a disease in a population of 30,000 and new cases 300. Okay, the population is 30,000. New case is 300. The question they are asking is incidence. Okay, let us learn the concept, then we will come back to the question. What is incidence means what? Incidence means number of new cases, okay, at a particular time. Let us assume that's 2022 by population at risk, not everyone. Population at risk multiplied by 1000. Usually we express in terms of 1000. The number of new cases by population at risk multiplied by 1000. The incidence will tell you, okay, it is used for etiological hypothesis. Yeah, to study the natural history of disease, we can use incidence. But incidence, what is the, which study will give you incidence means? Incidence will be given by longitudinal or cohort study. Cohort study can give you incidence. Cohort study or longitudinal study. So number of new cases at a particular time period by population at risk. Now let us see here what is incidence here. We'll see here incidence. Now incidence, what is this population? 300. Number of new cases 300. What is the population? Population is 30,000. And usually incidence we express in terms of 1000. Usually. We can, other ways are there, but usually express in terms of 1000. Okay, fine. Yes. The answer here is 10. 10 per 1000. Incidence is 1000, guys. 1000. Sorry, 10 per 1000. Incidence means number of new cases. New cases. Go to the next question. In a study of 200 smokers and 600 non-smokers were followed up for a period of 10 years. Okay, followed up. The incidence of hypertension they want to find out. Okay. So smokers to hypertension. Smokers to hypertension. What study is this? Yes, this is what? Cohort study. Okay, it's raining heavily here. Hope we don't have power cut here. Now, so smokers, hypertension, it's a cohort study. Okay, so cohort study. So we have two set of people are there. Okay, so out of 200 smokers, 60 developed hypertension. Out of 600 smokers, 30 develop hypertension. The question is, what is risk ratio? What is risk ratio? We'll see the concept first. What is risk ratio? Risk ratio means it is relative risk. A relative risk is also called as risk ratio. What is the formula for relative risk? Is incidence among exposed by incidence among non-exposed. Incidence among exposed by incidence among non-exposed. This is relative risk. Relative risk talks about what? Relative risk talks about strength of association. Strength of association. That means, okay, equal to 1 means no association. More than 1 means positive association. Less than 1 means negative association. You could have seen the videos actually. Now the relative risk, okay, we have to find incidence among exposed by incidence among non-exposed. Let's take here, okay, fine. Let's. The incidence among exposed. Incidence among exposed is, okay, how much it is? So 60 people developing disease, 60 out of how many? 200 smokers. Okay, multiplied by, so out of 200, not 2000. 60, okay, by 200 multiplied by 1000. Okay, so what will be the value? Okay, fine, 5, that is 300. Incidence among exposed is 300. The incidence among non-exposed, we'll write in short form. So how many people are there? 30 people. Out of 30 people, 600 were non-smokers multiplied by 1000. Okay, fine. How much? That is 300 by 50. Okay, 50. Okay, 50. Now, what is the relative risk here? Relative risk will be how much? Relative risk or risk ratio is incidence among exposed by incidence among non. 300 by 50. The answer is, so what type of association is this? Okay, so equal to 1, no association. So that means what? Equal to 1 means no association. Relative risk, no association. More than 1. More than 1 means positive association. Okay, less than 1 means negative association. Positive association means here we are talking about risk factors actually. Risk factor. So more than 1 positive association, less than 1 is negative association. So the answer for this question here is, the answer is 6 actually. That is, okay, fine. Next question. Let us see some next question. I'm teaching it crisply, guys. I'm not going very detailedly. This is enough, more than enough for your exams, guys. Now, a party was attended by 110 people, out of which 40 people did not eat fruit salad. Okay. From the rest who ate fruit salad, 55 developed disease, food poisoning. So the cause here is food poisoning. So food poisoning cause here is fruit salad. Okay, fruit salad is the main culprit here. Fruit salad. Okay, fine. The question is, what is attack rate? Attack rate is a special form of incidence rate. Okay, we will see the concept, then we will come back to the. What is attack rate? Attack rate formula is number of new cases occurring in a particular time by population at risk, and this is expressed in terms of percentage. It's a special form of incidence, but usually incidence we express in terms of 1000 here, but here we express in terms of percentage here, percentage. So look here, what is it? Okay, when will we use attack rate? Attack rates are used during outbreaks or epidemics. Suppose in a village, okay, there is a outbreak of cholera is there. Okay? So then we can use this attack rate. So attack rates are used during outbreaks actually. Right. Now we'll go back to the question. Go back to the question. The number of new cases, how much? 55 is the number of new cases. From the rest, okay, how many people are exposed? Okay, people are at risk. 110 people are totally there, but out of them 40 did not eat fruit salad. Okay, so 110 minus 40, that is 70 actually. 70 multiplied by 100. So that comes, okay, we have, why some of you may say that why not 110? Okay, so because so 40 people did not eat fruit salad because they are not at risk actually. Okay, so what is the answer will be 78%. Okay, the attack rate for this condition is 78%. Go to the next question. So far we have seen the questions related with epidemiology. Let us learn some other calculation. In a study for contraceptive efficacy, 100 women used a contraceptive over a period of 2 years. The number of accidental pregnancies was 10. Calculate Perl Index. What is Perl Index? Let us see the concept first. Perl Index. Okay, it measures contraceptive efficacy. How good a contraceptive. This is two ways we can use it. One is Perl Index, second is life table analysis. So what is the formula for Perl Index? Perl Index, the formula is accidental pregnancies by total months of exposure. Accidental pregnancies by total months of exposure multiplied by 1200. So how many accidental pregnancies? For anything you can measure. Okay, condom is there, OC pills we have, okay, copper T we have. Okay, so accidental pregnancies by total months of exposure. Right. Now, what is the accidental pregnancy? Let us go back to the question. This is one way. The other method is one. This is one method. The second method is life table analysis. Okay, this is second method, life table analysis. Right. Now look here, you go back to the question. Okay. So 100 women used this contraceptive over a period of 2 years. The number of accidental pregnancies was 10. Calculate Perl Index. Calculate Perl Index. Now let us see this. Right. Now what is the accidental number? Numerator is what? Numerator is number of accidental pregnancies 10. Denominator is total months of exposure. Okay, can you tell me how much is the total months of exposure? Okay, 2 years, it is 24. 24 is for what? Most of you say 24. 24 is for what? 1 woman. How many women we are following? We are following 100 women. Multiplied by 1002. So this is 10 by 2400 multiplied by 1002. This is 2. So 5 per 100 women years. This is how we have to calculate. 5 per 100 women years. This is Perl Index. This is Perl Index. So we have to calculate the calculation. The number of accidental pregnancies were 10. So calculate Perl Index. Okay, 5 per 100 women years. The next calculation. This comes in the chapter of environment. In a community well water, 𝐒𝐻𝐂𝐈𝐀𝐋 apparatus shows third cup as blue. So what will be the requirement of bleaching powder? Okay, so what is the purpose of 𝐒𝐻𝐂𝐈𝐀𝐋 apparatus? 𝐒𝐻𝐂𝐈𝐀𝐋 apparatus measures chlorine demand of the water. Okay, 𝐒𝐻𝐂𝐈𝐀𝐋 apparatus measures chlorine demand of the water. How much is the chlorine requirement? Okay, every water is varies. Okay, how much is the chlorine requirement? So it has 6 cups. It will have 6 cups. Each cup corresponds. So let us see the concepts here first. So it will have 6 cups. Okay, in 6 cups you add water as well as the reagent. Okay, then there will be a change in color of the cup. Okay, the first cup, the starting cup where there is a change in color. Okay, we have to take that as the first cup where the color change is there. So each cup corresponds to, okay, 2 grams of bleaching powder. Bleaching powder. Each cup corresponds to 2 grams of bleaching powder. Okay, to disinfect 455 liters of water. Okay, 455 liters of water. Each cup corresponds to. Okay, each cup corresponds to disinfect 2 grams. Requirement is 2 grams, guys. The key point here is 2 grams. Okay, fine. 2 grams. Okay, fine. Now 2 grams to disinfect 455 liters of water. Okay, now we will go back to this. The question is, out of 6 cup, third cup is positive. Okay, third cup means what? So 3 into 2. Okay, 6 grams is required for 455 liters of water. Now how many liters of water is there here? 910 liters. So 9,100 liters are there, not 910, 9,100 liters. So out of them, so you have to divide it 455. So this is 20. Okay. So 20. How many grams we already said? Okay, 3 cups means 6 grams. Okay. So this has to be multiplied with 6. That gives 120 grams. Okay. So I'm repeating again. So this Horex apparatus measures chlorine demand of the water. So it has 6 cups are there. Each cup corresponds to 2 grams. Okay. So you add the cup and you add water in it. Okay. And reagent. Based on the impurities in the water, the color change will happen. It may be in the first cup, or it may be in the second cup, or maybe in the 5th cup or 6th. So here it says the 3rd cup is positive. From 3rd cup onwards it is. Okay, that means that water requires 2 grams of bleaching powder. That is 2 into 3, 6 grams of bleaching powder to disinfect 455 liters of water. So the question, how many liters of water are there? 9,100 liters. So you have to divide it, and total calculation requirement is, okay, 120 grams is the requirement. Now, birth rate in a population of 5,000 is 30 per 1,000 population. Okay, birth rate is 30. Calculate total number of expected pregnancies. Okay, this is a INICET question. So let us understand this. So this calculate estimation of number of pregnancies. Estimation of number of pregnancies. Okay, fine. Estimation. So first is expected number of live births. 2 components. This formula we are going to write in 2 components. Expected number of live births. Okay, that is Y is equal to root birth rate multiplied by population divided by 1,000. This is first step. This is expected number of live births. Second step is expected number of pregnancies. Okay, that is Z is equal to Y plus 10% of Y you are going to add. What is this 10% of Y? 10% of Y, what you are adding here is, that is called as pregnancy wastage. Abortion could have happened, stillbirths could have happened. Okay, so that we call it as pregnancy wastage. Z is equal to Y plus 10% of Y. Okay, now we'll go back to the question. These are 2 steps. Okay, estimation of number of pregnancies. First you have to calculate Y, expected number of live births, then you have to add 10% to it. Okay, now let us go back to the question. So the population they said is 5,000. 30 is the number of population. Okay, now let us see the question. So first Y is equal to 30 multiplied by 5,000 divided by 1,000. So that is 150. This is expected number of live births. Now the question says expected number of pregnancies. Okay, Z is equal to, so 150 plus what is 10% of Y? This 10% of 150 is what? Is 15. So Z is equal to 160. So the expected number of pregnancy in that particular area is 160. This is how we can calculate. Actually, we can calculate. So who does this job? Okay, in a subcenter area, it is the responsibility of A&M. A&M, she does this calculation, and she calculates. She estimates the number of pregnancy. Based on this, she can order for IFA tablets, DT injection, all those things she can order. Fine. Go to the last question. In a town with a population of 20,000, okay, 456 births were there, and 56 were dead born. The total reported deaths were 247, out of which 56 deaths occurred in the first 28 days, and another 34 died between 28 days to 1 year. Calculate infant mortality rate. Question is infant mortality. Let us see the concepts here. What is infant mortality rate? IMR. Okay, infant mortality rate is a number of infant deaths. Okay, infant deaths. Okay, can you tell me what is infant deaths? Infant death is 0 to 1 year. 0 to 1 year by, okay, what is the denominator? Number of live births. Number of live births multiplied by 1,000. So number of infant deaths by number of live births. Okay, fine. Yes. Now let us go to the question here. Infant deaths means 0 to 1 year, actually 1 year. Now let us go back to the question. Okay. So here the total number of deaths reported, 56 deaths were reported in the first 28 days. What is that? This is called as neonatal deaths. Neonatal deaths. Second, another 34 died between 28 days to 1 year. This is post neonatal deaths. Okay, post neonatal deaths and post neonatal deaths. Okay, fine. Now the numerator is clear here. Okay, how much is that? So that infant deaths means neonate and post neonate. That is, so what is IMR? 56 plus 34 numerator. What is the denominator here? Live births. The question says that how many were live births here? Okay, the total births is 456. Out of them, how many were dead born were there? 56. So the key catch here is, this is the key, 400. So the denominator is 400 and multiplied by 1000. So what is the answer here? 90 by 400 multiplied by 1000. 90 by 400 multiplied by 1000. So am I clear? So what will be the answer here? Yes. So the answer will be 225. 200. So the answer for this question is, so the key point here is that, so you have to see that the key catch here is that you have to take only live births. Okay, so you have to subtract the stillbirths from the total births. One, and numerator includes infant means neonatal as well as post neonatal, that is 0 to 1 years. So hope you understood these concepts. Okay, hope you understood this concept. Okay, see you soon in the next video, guys. Thank you.